Okay. So you can turn on your video, Nivedita.
Yes, ma'am. Ma'am, shall I start?
First you need to turn on your video. You are not visible on the screen.
Yes.
Yeah, now you can.
Okay, ma'am. Good evening, everyone. I'm Nivedita, and my team members are Shraddha, Aishwarya, and Mallikarjun. And our topic is automation trends in glass making plants. Next slide. So these are the contents: automation trends in glass making plants and glass making process and its control. Next slide. Automation trends in glass making plants. Due to many developments made in glass making plants, glass making processes, demand for more sophisticated instrumentation and control for improving product quality, uh, productivity, saving of energy and labors has become greater. Also, the application of automation in manufacturing process is to reduce cost, improve quality, increase productivity, and to reduce dependency on manual control. And the reduction in the labor force has become the smallest achievement in automation. And it has made major savings, but not by removing labors, um but by improving quality, productivity, efficiency in a way, not achieve in a way by improving them, not achieved by men in the processes. Next. So almost the emergence of cost-effective DDCS, which are derived from DCCS, glass making plants have started converting from analog instrumentation and PLCs to these systems. So the number of packaged DCCS have widely used in glass making plants, crystal glass, optical glass, providing plate glass, bottles, and many such other applications. Thank you. And next will be continued by Mallikarjun.
Okay, you can turn off your video. Mallikarjun, you need to turn on your video and continue. Mallikarjun is here. First, you need to unmute yourself. Mallikarjun. Mallikarjun. Turn on your video and continue the presentation.
Turn on your video. Continue the presentation.
Next slide.
You have to turn on your video also.
You have to turn on video also.
Good evening, one and all.
You are not turned on your video, Mallikarjun.
You are not turned on your video, Mallikarjun.
Not visible on the screen.
Not visible.
Okay. Yeah. Now you can continue.
Good evening, one and all. Good evening, one and all. My topic is glass making process and its control. With the advancements made in glass making process, it leads to demand for more sophisticated instrumentation and control for improving product quality and increase in productivity and saving energy and labor. It leads to it has become more widely. Next one. Glass making involves a variety of distinct processes like preparation of mixture of raw materials, followed by melting and molding, etc. Uh, uh, Example, sequence control is used for preparation of mixture of raw materials, and feedback is used for melting process. Mm, in the in the material preparation, raw material fed in bunkers are weighed according to a present recipe, mixed in blender and charged into service offer.
Your part is
Next will
over.
be continued by Shraddha.
Okay.
Yes, ma'am.
Okay, Shraddha, you can continue by turning on your video. You can mute your video, audio and video, Mallikarjun. Shraddha,
Yes, ma'am.
you can turn on your video and continue.
Okay, ma'am. Okay, ma'am. Shall I start, ma'am?
First, turn on your video.
Can you able to see, ma'am?
Okay.
Okay, ma'am. Next
You are-
slide, ma'am.
Okay. You are going to start from here?
Yes, ma'am.
Huh.
Hello, good evening, everyone. My part of discussion is material preparation in glass making plant. Look at the diagram. There is a cullet, service hopper. There is a furnace, and these all things are used in a preparation of a glass. Initially, glass is a transparent or a translucent material, and it is in the process of making glass, there are materials used are lime, soda ash, limestone, and sand, silicon, and these three materials are mixed in a these three materials are mixed and made a powder, and these three materials are heated with the cullet, and cullet is a piece of a glasses which are piece of glasses which are used to heat with these powder mixture because it reduces the temperature of the raw material, and this mixture is heated for are about 1000 degrees Celsius, and it is made to cool it is made to cool, and at the end is the mixture is cooled for about cooled for more large amount of time because it can't be cooled suddenly, and the next process is molding of the glass. Ma'am, next slide, ma'am. Next slide. Okay, ma'am, I got it. This is no, ma'am, back.
Previous.
Yes, ma'am. Yes, ma'am. Previous slide, ma'am.
Okay.
This mixture, the mixture of these three materials is taken in the bunker, and these materials are taken in a bunker, and mainly these three materials are mainly controlled by a sequence control, and by concentrating in these areas, detection of the level of the service hopper needed to be needed for automation and a stop of the material preparation process. These materials are taken in a service hopper, and the detection of these detection level detection level of these of this mixture is is necessary to be observed. And the next part is the uh, automatic compensation for the moisture control of a silica sand during weighing. The moisture content of the sand has been observed because it might lead to some disturbance in the preparation of the glass. And automatic compensation of a zero shift of the weighing scale for a DDA system. The scale of the weighing machine has been observed so that it won't create any problem in the glass making. Next slide, ma'am. Uh, Glass melting furnace is used for melt a prepared material to obtain a glass. These mixtures are melted to get the glass to obtain glass. Primary control point for this process is a furnace temperature which is to be maintained. In this glass making process, the furnace temperature is to be maintained, and it is difficult to control the temperature. It may include the temperature of a raw material charge or a service offer charge. It might include some things. It is difficult to maintain the temperature because it changes due to the various disturbances have about 24 hours. Because of the change in temperature, it is difficult to maintain the temperature. The next slide is a video which is to be played. It concentrates on the automation in a glass making plants. You can clearly see the glass making process in the industry. Next slide, ma'am, is a video. I think it will play.
It may not play because you need to send that video file also, or since it is a YouTube link, it may. Okay,
Yes, ma'am, it is YouTube.
let me check.
Okay, ma'am. Larger the screen, ma'am. It is possible to larger the screen. Okay. Advertisement.
No, it's not a merry-go-round in that hot place down below. But like most glassware manufacturing plants, this one in Sydney has plenty of heat with lots of bang and patter.
Volume. Sound is not hearing, ma'am. Is it so for all?
Transferred to the press where stems are to be fitted. First appear as small globs of molten glass from melting furnaces heated to 2600 degrees. The heat treatment continues as the sections are joined. There's yet another heating process if the glasses are to carry patterns or colors. Manufacture of containers for foods is an important part of the glassware industry in Australia, following the development of self-service grocery stores. These will be 6-ounce containers for sandwich spreads. It's one industry where quality control is a must, but there's little waste. Anything rejected goes back into the melting pot, and the process starts all over again. Some of the glassware is exported, but most of the products will end up in Australian homes in one form or another. All sizes, all shapes, catering for all tastes and all thirsts, from a gallon to a gulp. And for a real handful of drinking, try this one. But from the Champagne Charlie to the best in beer drinkers, the local glassware industry is catering for a multitude of thirsty tastes. Now out of the time tunnel, fashions for the...
Next part will be continued by Ishwarya.
Suza ma'am.
Singh sir, Radha ma'am, Geeta ma'am, Varua miss, Sharma sir, Shari ma'am.
Shinde sir.
Okay.
Okay, ma'am.
Is it over?
Yes, ma'am.
Aishwarya has to continue.
Yes, ma'am.
Aishwarya, you can continue by turning on your video.
Okay.
Yeah.
Good evening to the block diagram of the glass melting. In this, the fuel is diverted to the three systems and it burns on the three. Next slide. Next slide.
Okay. Previous one.
Fuel. No, ma'am. Previous one, ma'am.
Is it okay?
Okay, ma'am. Fuel flow to each burner the individual flow set pointer and it is obtained by multiplying each system ratio total flow output control signals. Burners are alternatively switched to both the north and the south bank for every 20 minutes to accumulate generators. That is, it needed for case temperature. The switch is controlled by the sequence control, which operates to limit flow with the program setter, and the furnace is subjected to the and control by burners are in a operation. Pressure control output formed quickly with the is over the switch and the program setup. Oh,
Okay. Let.
next slide. Thank you.
Okay. So you can turn off your video. Next batch is batch before. Who is going to present first from batch before?
Ma'am, I'm presenting first, ma'am.
Sakshi?
Yes, ma'am.
Okay. So let me share your this one PPT. You can start the presentation. This is your set of PPTs.
Yes, ma'am.
You can
Can I start?
Yeah.
Good evening to one and all. The topic given to our batch is water and wastewater treatment plants, and this is presented by Aishwarya, Chaitra, Kajal, and myself. Ma'am, next. This is the content which which me and my batchmates are going to discuss in this presentation. Introduction: wastewater treatment process, automation trends in water works and wastewater treatment plants, TCCS application in water industry and filtering control system. Right. As you all know, the wastewater and all is dumped into from the factories, from the houses, are all dumped in the rivers and lakes, and which is unhealthy to the environment. So the management of the water, which is being dumped in the lakes and all, is being a difficult work by the is being a long substantial function for all the municipality workers. So the water purification, like wastewater treatment can be done by two processes. By that is the water softening and purification. Water softening is removing or reducing the hardness of the water. That means the the waste wa- the minerals which are of no use are removed. That is called as softening. And purification is the removal of organic matter and microorganisms. The unnecessary microorganisms and organic matters which are unhealthy for the health is being removed, and that process is called as purification. Next slide. This is the municipal water work flow chart. In this, there is the raw water, which has a hardness of 376 ppm, is being aerated through the aerator, and it also has a raw water control to so that the amount of water passed through the aerator can be controlled. Then it is partly softened. It is the raw water which is passed is partly softened in the in the container, and in the as you can see in the left right corner of your diagram, there is a chlorine which is added to the water for softening. Chlorine is added to destroy the pathogenic microorganisms, and above the and even activated carbons are added to remove the odors and improve the flavors of the water. Similar, next slide. This is what I've explained in this. The raw water is aerated from the lakes or ponds, and it is also partially softened. This is chlorine can be added to destroy the pathogenic microorganisms, and there is an easy method of disposal, that is dilution. Dumping in the river or lake is no longer tolerated, as it is injurious and it may affect the environment. Next. This is the activated sludge water treatment. In this method, there are totally three methods which are followed. That is the primary, secondary, and tertiary. Primary method is used to remove the BOD of the sewage for nearly 30 to 60%. BOD is a biochemical oxygen demand, which means that the amount of oxygen present uh, in the water required to remove the materials from the water, and for the purification. And the secondary method is used for the more purification of the water of up to 85 to 90% of the BOD. This activated sludge, what you can see in the diagram, is one of the most effective methods for removing all the suspended and dissolved substances from the water. And there is a combination of secondary and primary method which helps in the tertiary sewage treatment. The tertiary sewage treatment helps in the removal of the pollutants and with no BOD. Ma'am, next part is continued by Kajal.
Okay. Kajal has to join now. You can turn off your video. Kajal will join and continue. Turn on the video, Kajal, and then you can continue. Yeah, you can continue, Kajal.
Next slide.
Visible slides?
No, ma'am. No, ma'am.
No? Or you can just continue without turning on your video. Maybe there is a problem with your bandwidth.
Next slide, ma'am. Hello.
Huh. Is it okay now? Huh. Can you
Ma'am,
continue?
slide is not. Next.
I think I have scrolled the slide. You want me to go more to the next slide again?
Yes, ma'am. This one, ma'am.
Okay. You can start.
All this, so my topic is automation trends in water and wastewater treatment. The basic techniques for operation and control of water and wastewater, which concerns water quality control and human interface for operating plants with high safety. There are three basic rules in this type. The first one and the primary objective is the quality of the purified wastewater. Second one is supply and disposal must be ordered under all the circumstances. Institution must operate economically. Waterworks have the system they have the machines such as pumps and motors and engines, which have to be operated infrequently and in every situation, in every atmospheric situation, they have to work reliably as reliably under hurricanes, under typhoons, etc. Analog system did not lend themselves to automatic diagnosis of equipment. Hence, it results catastrophic operation and also causes problems for public and water work authorization. There are severe problems in environment conditions such as corrosive gas, dust, moisture, which results which affects the life and control system. And it is very difficult to predict the type and the concentration of uh, corrosive gas which is generated in wastewater treatment because it depends on the season's ambient temperature, quantity and quality, etc. Next slide, ma'am. There are several problems which are encountered using analog controls, such as slow response, fluctuation of dissolved oxygen, non-linearity of actuators, and etc. To overcome this, distributed computer control system, it has been possible to solve problems. So hence, this has been applied extensively in many municipalities. Thank you, ma'am. Next slide will be continued by Chaitra.
Okay. Next, you can join. You can mute yourself. Who is going to present next? Okay, who will continue?
Chaitra, ma'am.
Chaitra. Okay, Chaitra, turn on your video, unmute yourself, and continue the presentation. Chaitra is here. Chaitra, are you listening? Yeah. Turn on your video, Chaitra. Unmute yourself. Okay, I have unmuted you. Turn on the video. Yeah. Can you see the slides?
Yes, ma'am.
Can you continue?
Good evening, one and all.
Hmm.
Yes, ma'am. DCCS application in water industry. DCCS is a distributed computer control system. DCCS, now DCCS is used in many facilities. DCCS level, individual control level, group control level, and process control level. DCCS acquires the data and process it as close to the process as possible. Next slide. The
Now mute yourself.
water works process control using protocol diagram. In this diagram, feeder bus is used to interconnect the dry control with the process control and the group control levels. Feeder bus can be transmits the state signals and sensor signals. Next slide, ma'am. Local control switches are located above the dry control level. The function by the group control level is the control and managing of the wells. The limits for the level performed at the dry control level. The dry control the limits for the water level is performed by the drive control level. Feeder bus transmits the state signal, sensor signals, and signals to the autonomous local operations. Vertical cable as usually dispatched with the feeder bus. Group control level is one, and the level in the it is formed by a number of multipurpose processing stations. One station is one station for instance that is provided for the controlling the filter basins. Thank you, ma'am.
Okay, next.
Ma'am, myself.
Okay,
Aishwarya, ma'am.
you can turn on your video and continue. And one more caution
Yes,
before
ma'am.
you can begin. Many people are leaving the meeting. You have to stay in the meeting till the end because I need to discuss something. Don't leave the meeting. Others. Okay. Aishwarya, you can continue. Turn on your video and continue.
Yes, yes, ma'am. It's on, ma'am.
Not visible. Just a minute.
Yes, ma'am.
Continue.
To everyone, continuing control systems. The figure describes the mode of operation of a filter. Uh, it has some walls, raw water inlet wall and clean water outlet wall, and sludge wall. Firstly, during if you want to filter, like filtration, we need to close the raw water inlet wall and clean water outlet wall. After closing this, The LIC and PDIC discuss, these are the measuring points. LIC is a filling control level control. It shows the water level above the filter bed, and PDIC monitors the amount of pollution in the and if the pollution level crosses the minimum pollution value, then the minimum multi-purpose processing station has to switch the system over to flushing. This uh, multi-purpose processing station comes under group control level. As described in the previous slides in waterworks, multi-purpose processing station comes under group level, whereas there are three levels: individual level, which is the bottommost level, and then the control level, group control level, and then comes the process control level. This comes under the group control level. And now clean water and raw water walls should be open, and the sludge wall should be clean. Raw water and clean water should be closed, and sludge should be open, and compressed air should be allowed in it so that the filter bed uh, loosened due to compressed air. And after some time, backwash water also starts the flushing of. It actually starts the flushing process. Um, a servicing unit can be connected to the multi-purpose processing station, which acts as a man-machine communication. Ma'am, next slide. Have explained, and last one is the remote bus consists of a single twin axial cable. This works over the entire water networks, and to make this remote bus redundant, we need the second cable of this diverted to the another site, because if any cable is spoiled, then whole network won't be disconnected. Ma'am, next slide. In the process control level, man machine communication is used. In this process control level, that is the top level, in man machine communication is used, and the elements of this it can be a display unit, it can be a printer or a lamp, it acts as a output display unit. And higher order task has complex calculations such as requirement forecast calculations, energy management, correlation calculations. It comes under process control level. Thank you, ma'am.
Okay. Right. You can close your video. Next, last batch. Who is going to begin in the last batch?
I'm not Shrish.
Shrish.
I will.
Okay. Shrish will start the presentation. Let me put your PPTs, then you can start. Okay.
Hello, good evening to everyone.
Shrish, you can turn on your video first.
Hello.
Turn on your video. Not visible.
Hello, good evening to everyone.
Video
Today
is.
I am going to present on automation trends in off.
Video is not visible. Okay, now continue.
Today I am going to present on automation trends of oil and gas. Offshore oil gas advanced equipment structure, the proper knowledge of offshore of an oil and gas, rig environment, and application and automations are less
First, I have to give the introduction to the next slide. The offshore oil and gas industry is a complicated married structure and workforce with proper knowledge and oil gas rig environments in the industrial robotics and automation are less active. Thus, the development of oil field vision of the potential roles and roles are used offshore oil process can emerge the those can emerge the process must be. There are many products and services related to oil equally substantial potential for market within the industry. There is which petrol can access and pass through the upstream, downstream. With these models, we can extract the petrol from the upstream oil petrol company refers to oil and the recovery of crude oil from the ocean and sea. The oil and natural gas is also known as production. Looking for potential of oil and gas explorative wells substantially using these wells to recover, bring the crude oil and natural. The midstream oil gas really point to upstream. Midstream process commonly refers to the and storage to the product because to produce the crude oil and pipeline quality gas for an for the people. Gas pipeline in the midstream are naturally gas may color in the bypass the downstream oil gas. Thus, the demand of for energy oil industry to demand for the energy commodity. The downstream oil refers to the refining of crude and the selling of the natural gas and other products derived from the crude oil such as liquid petroleum gas, LPG, and gasoline and petrol and jet fuel, diesel oil. These are all the that's consumed through the thousands of products. These products, petrol, diesel, and natural propane lubricants, fertilizers, as well as pharmaceuticals, etc. Next, next slide. The figures show some of offshore platforms. Figures is the two process computer systems, communication network, and 16 terminals and 7 operating workstations distributed to the platform complex and manage the data and communication, processing events, and partial process control. The full delegated from the special control unit connect the SCADA system are capable the means of approximate logic to handle and shut down the situation built in. The heart of the distributed computer system is the operator console by the two workstations for process monitoring and emergency shutdown and the three workstations for fire and gas sensor signals. Used in the control room of the plant. Also, the additional operators workstations are planned and display the system configuration for the availability purpose as well as to the transparency. Two subsidiary stations are to module with the possibility to process the plant as well as due to the operator to the survey and the status whole plant quickly obtain the expected data and give the priority to the current plant system. Thus, the avoiding the efficiency and also to limit the control function carried out by the system. Thus, this system is to petroleum gas status. Thus, I will conclude my.
Okay. Who is going to take over next? Hmm?
Hello.
Hello, Shilpa?
Yes, ma'am.
Turn on your video. Continue. Shrish, you can mute your audio and video.
Ma'am, next slide.
Okay, you have to turn on your video also, Shilpa.
Ma'am, it's on.
Hmm? It's on?
Yes, ma'am.
Okay, continue. Continue.
Good evening, all. SCADA telemetry system for spectrum. In order to monitor the emergency situation, here we have two computers. One is for data concentration, another one is for data processing. These two computers are placed in a central computer station in the plant. The data can be transferred through a coaxial cable with a data transfer rate of 1 megabit per second. The data can be transferred between subsystems and SCADA onshore systems. Here, here we have two satellite telemetry systems which will be placed at a distance of 175 miles each from each other for establishment of data transfer between from both the devices SCADA and the onshore computer center. A 2400 bit per second communication link for SCADA system and onshore center and facilities also, and it and it also and it also connects the cable between mainframe and other network routers. Uh, 40, 4800 and the 1200 baud rate connects the data between mainframe and mainframe and ma'am, slide is not visible.
Not visible? Is it okay now?
Yes, ma'am.
Ah.
A 4800 baud rate and 1200 baud communication link for interconnection of SCADA system and the mainframe computer used for transfer production and prepared by the SCADA. A satellite communication is also used for extended telemetry system. This system is helpful for this system is helpful for compression of data, processing of data, and transfer of data. This system has some advantages. They are flexibility, reliability, and transparency. Ma'am, next slide. 10 digital technology trends in oil and gas industry. Artificial intelligence. This application helps to surveying and monitoring of continuous data, big data and analytics. This application helps to increase and increasing of data, Internet of Things. This application helps us to store the large amount of data and that data can be used whenever we connect to the internet. Electron monitoring. The hardware systems such as sensor device can be uh, connected to the another device through a internet, and these devices can be monitored through a remote. Transparency and automation. This reduces the human efficiency and human work. Next will be continued by Shruti. Thank you,
Okay.
ma'am.
Okay, you can mute yourself and turn off your video. Shruti will continue. Shruti, you have to turn on your video and audio.
Ma'am, actually it's raining, ma'am, so low network.
Only audio at least.
Yes, ma'am.
You can continue the presentation. Slides are visible.
Yes,
You see.
yes.
You can continue.
Yes, ma'am.
Hmm.
Let us continue. rise in cyber basically there is done by the computer algorithm, and this is the evolution in the world because anything we do in nowadays even normal everything is auto. So even in gas and the help of evolution, we are able to manage the assets. And in important and big data analysis and even digital identify the problem and to manage and also to detect the future so that is why it is more important. And the computers nowadays even business goes on change as happens. So it needs to be updated regularly. The next one is digital improvement. It is to uncertain and violate markets. The CIO information for the gas and oil. They have to maintain enable automation so that so they have to maintain enable automation. With on source on demand are compatible for other and even because of this cost also we can elastify the cost can go our cost of then we can next is emergence of disruptive business models. Disruptive nowadays IT models service they are that is lower yeah support the next the other leadership mainly some other so as and when the things our instant automation so that nowadays all the oil and optimization transfer previous slide
Shall I move on to the next slide?
previous slide
Previous, okay.
next is CIOs become change agents. These the already involved workers they are less what we call now as the industry 4.0. So the CIOs of the they have to make sure that everybody is protected and work for products and products that the people buy it or not is based on products and according to oil and experts he says that 62% of the they are mostly based on product centric developments rather than people buy it or not. Next slide. Key benefits of oil and gas industries. Robotic drilling, as the name itself, drilling is unmanned. Robots will do the drilling fully. They are capable of the pipes and they also replace the casing threads. In addition, it also offers self-movable automated drill string. It is fully automated and they can be moved an oil field from one well location to the another well location, which is difficult for the next one is in-pipe inspection. Inspection, as the name itself indicates, they detect the cracks, corrosion, and the defects in the pipe. These robots, so they are having non-destructive systems that are inserted within the network of the pipeline. These are designed to communicate throughout the relay node, sending information to one single base station. Next is unmanned aerial vehicles. Nowadays, the drones are even in the marriages. So the same facility, oil and gas. They also use for inspection of tanks, pipes, refineries. So they build control techniques, inertial navigation, tracking control, and the data fusion. These make effective for the exploration of oil and gas reservoirs in extreme environments where it is hazardous for the human beings. And next slide. Hence, we'll conclude that the oil and gas refinery work with the automation, with the evolution, maybe it may be some difficulties to adopt, but we can adopt it because it cut down the human risk factors, and with the help of common innovation process, all the refineries automation techniques which will be helpful, and there will be reduced communism in, and operating cost will also be less with the help of environmental and health safety also maintained. We call it as EHS. Thank you.
Okay. I'll stop sharing the screen. Okay, how many are back? Two have left. Okay, anyhow, I appreciate all the three batches. You have done well. Slides were also good, and you have explained in a convincing manner. Okay, so this will be considered for your assignment. Now I have something which I want to ask you people. Yesterday I talked with a company person uh, from Hyde, and they are ready to organize a webinar on industrial automation and current trends or advancements in industrial automation. So if you people are ready to attend the webinar, I can proceed further. I can discuss with the higher authority and we can organize a webinar on industrial automation if you are interested. So I want your opinion regarding this. Can you give me your opinion on this? A webinar series on industrial automation. You all of you can unmute yourself.
Is it for one day or like?
No, maybe two sessions. He told that he has conducted one session for us. So I felt that it is interesting. It is mainly concentrated on industry 4.0. So he agreed. He said that he can have one or two sessions. So if you are all are interested, and I need to arrange some other students also, because only for 20 students. Exclusive webinar may not be arranged. So some 40 to 50 students he want. If you are interested, then I can proceed further. All of you can unmute yourself and give your opinion. It is not for one day, maybe one session or two session of 1 hour and 1.5 hour. Yes, I'm waiting for your reply.
Yes, ma'am.
Yes. Okay. You are ready.
Yes, ma'am.
Uh-huh.
Yes, ma'am.
Okay. So maybe in the next week I will talk with the authority, and since it is a interdisciplinary, multidisciplinary, maybe the students from mechanical and automobile branch, because it is mainly a hydraulic, pneumatic and automation PLC based automation company. So let me talk with those people also, and we can arrange for a webinar from the company person himself. Okay. Uh, these 2 days presentations, whatever you have done, uh, uh, I will be posting them in the Google Classroom. The recording itself I will be posting, so that you can go through the your presentation, how you have done the presentation, and maybe I also want to discuss how about the coverage of the remaining part. Some small part in third unit is remaining. So how about the coverage? Do you want me to take some more classes online? or a PPT with audio will work? Yes.
Online class.
Hmm?
Online class.
Online. Maybe I will arrange one online class where I will cover the remaining part of the third unit and revise the third unit in entirety, right? And I will also be giving some questions based on third unit for preparation. It is not like an assignment, it is just for your preparation. That may help you. Will it be okay? Will it be okay?
Yes, ma'am.
Okay, right. Maybe I'll tell you, I'll inform you when I'm going to take that one, and I'll also inform you regarding the webinar which may be arranged. Maybe because I need to take the permission of the higher authority also. If they permit, then I'll go ahead and arrange a webinar for you. Okay. So now I'm going to close the meeting. Anything you want to discuss other than this? Anything you want to discuss other than this? Any doubts?
No, ma'am, nothing.
Okay. So shall I close the meeting?
Yes, ma'am.
Okay, then I'll end the meeting. Okay, thank you.
Thank you, ma'am.